So let's look at a couple more examples, and this should wrap up our videos on radical equations. Let's take a look at some examples where you get a radical equation that will actually simplify to a quadratic equation once you manipulate it a little bit. Okay? So here we're given y is equal to the square root of 2y plus 3. Okay? So let's go ahead and square both sides of the equation. And we'll get y squared is equal to 2y plus 3. Now remember, because we squared both sides, we're going to have to check our final answers to make sure that they work. Okay? And since we have a quadratic equation, we might end up with more than one answer, so you may have to check more than one answer as well. Okay, so here we can now set this whole equation equal to 0. We can take 2y plus 3 away from both sides. So this will become y squared minus 2y minus 3 is equal to 0. After we distribute that negative, we'll get that. Let me label the other side too. Minus 2y plus 3. Okay. So now we can solve this just like we would any other equation. We want to, any other quadratic equation. We want to find two numbers that multiply together to give us negative 3, and that also add together to give us negative 2. Okay? So I am thinking negative 3 and 1. So we have y minus 3 and then y plus 1. Okay, so that means that our two possible solutions here are going to be y equals 3 or y equals negative 1. If we plug either of these in, we would find that one of these would be equal to 0, and therefore the whole thing is equal to 0. And so we will have y equals 3 and y equals negative 1 as possible solutions. Okay, but let's check them just to make sure. Let's check y equals 3 first. All right, so we should get something that makes sense here if we plug in y equals 3. So let's do that. So we'll have 3 squared is equal to the square root of, oh wait, no, we don't want to square that because the initial one didn't have that. We just initially had y. So we have, sorry about that. We have 3 should be equal to the square root of 2 times 3 plus 3. All right. So then we have the square root of 6 plus 3. All right. And then we have, therefore, the square root of 9, which is 3. So 3 is equal to 3, and therefore y equals 3 must be a valid solution. Okay, so this one is good. All right. And now let's check negative 1. So here we have negative 1 is equal to the square root of 2 times negative 1 plus 3. This will be equal to negative 2 plus 3, which is equal to the square root of positive 1. Okay, but the square root of 1 is just 1, so that's not going to work. Okay, so these two are not, sorry. So this particular equation is not a valid solution. So we know that y equals 3 is a valid solution. So now y equals negative 1 is not a valid solution. Okay, let's look at this one. Here we have the square root of 5w minus 4 is equal to w. Okay, so let's go ahead and square both sides, and we'll end up with a basic quadratic equation. So we'll get 5w minus 4 is equal to w squared. And through moving some things around, we'll end up with w squared minus 5w plus 4 is equal to 0. And now we should be able to solve this just like any other equation. So, or any other any other quadratic equation. So we want to find two numbers that multiply to give us 4 and add to give us -5. I'm thinking -4 and -1. So we have w minus 4 times w minus 1. Okay, that's, yeah, it should work. So that our possible solutions are going to be 4 and 1. And now we just have to make sure that each of these makes sense. So here we have the square root of 5, well, let me label this. Sorry. We're going to check our solution now. We have the square root of 5 times 4 minus 4 should be equal to 4 if everything makes sense. Okay? So we'll have the square root of 20 minus 4 is equal to the square root of 16, which is just 4. So yes, that checks out. All is good. Okay, and again, we got that, just in case that wasn't clear, we got that by saying that we should have the square root of 5w minus 4 is equal to w, where w equals 4. And we'll do the same thing again here for w equals 1. So let's check for w equals 1. We'll have the square root of 5 times 1 minus 4 should be equal to 1 if everything checks out. So we'll have the square root of 5 minus 4, which is equal to the square root of 1, which is just 1. So that also checks out. So we know that our final solution is going to be w equals 4 and w equals